Welcome for the video for tutorial 8. We'll firstly be looking at the exercises under section 2.8 in your textbook, and we're looking at number 9b. It says, suppose that y equals the square root of 2x plus 1, where x and y are functions of t. If dy dt equals 5, find dx dt when x equals 12. Okay, so let's just write down what we are given. So y equals the square root of 2x plus 1, so I'm just going to write as 2x plus 1 to the power half. I want to find the dx dt. So what I'm going to do is I'm going to apply implicit differentiation, and then I'm eventually going to make dx dt the subject, and then I'm going to substitute in what I have. In other words, I have dy dt equals 5 and x equals 12. I'm going to substitute it into that equation to solve dx dt. So let's apply implicit differentiation. On the left hand side we get dy dt. On the right hand side I get a half 2x plus 1 to the power minus a half multiplied by the derivative of 2x, which is 2 dx dt. So now what I have is I have dy dt equals the half and that 2 just cancel out, they make 1. Then I have 1 over the square root of 2x plus 1 dx dt. So that means that dx dt is going to be the square root of 2x plus 1 dy dt. And I want to find dx dt when x is 12 and they give me that dy dt is 5. So I'm just going to substitute these values in here. So now I get 2 multiplied by 12 plus 1 multiplied by dy dt, which is 5. So I have the square root of 25 multiplied by 5, which is 5 multiplied by 5, which is 25. And that's it. We're doing number 33 next. The top of a ladder slides down a vertical wall at a rate of 0.15 meters per second. At the moment when the bottom of the ladder is 3 meters away from the wall, it slides away from the wall at 0.2 meters per second. How long is the ladder? So we start off this problem just by drawing what they tell us to get a little bit of a visual idea of what's going on. So we have a ladder standing against a vertical wall. So that's the wall, this is the ground. We want to determine the length of the ladder. Let's just call that L. So this ladder is standing at some height, let's call it y, against the wall, and it's some distance, let's call it x, away from the wall on the ground. So we want L. Next, let's look at what we are given. So they tell us that at the moment when the bottom of the ladder is 3 meters away from the wall, it slides away from the wall at 0.2 meters per second. So what that means is that dx dt is 0.2 meters per second when x equals 3 meters. That's the first thing. And the second thing they tell us is that the top of a ladder slides down a vertical wall at a rate of 0.15 meters per second. So that means that dy dt is minus 0.15 meters per second. Why minus? Because y, that distance of y, is decreasing. It's sliding down the wall. So that's why we have a negative. Our next step is going to be, we want to find a relationship between our unknown quantities. And that's nice and easy for us. Our unknown quantities are x, y, and l, so we know that x squared plus y squared equals l squared. So the idea of what we want to do here is we want to be able to use the information we're given in some way so that we can solve L. So we first need to get a dx/dt and dy dt so that we can substitute its values into the equation. So what I'm going to do is I'm going to apply implicit differentiation. So then I get 2x dx dt plus 2y dy dt. And remember, L squared is just a constant, so its derivative is 0. I can write this as y dy dt equals minus x dx dt. And I'm given dy dt, it's minus 0.15. I'm given x, it's 3, and I'm given dx dt, it's 0.2. So I can just substitute all of those values in, so I get y multiplied by minus 0.15 equals minus 3 multiplied by 0.2, and if I solve y, I get 4 meters. What was the original thing we wanted to determine? We want L. We now have x is 3, y is 4, so L squared is 3 squared plus 4 squared, which is 25. So that means that L, the length of the ladder, is 5 meters. Next, we are doing number 45. A plane flies horizontally at an altitude of 5 kilometers and passes directly over a tracking telescope on the ground. When the angle of elevation is pi over 3, this angle is decreasing at a rate of pi over 6 radians per minute. How fast is the plane traveling at that time? Okay, so what we're going to do first, once again, is let's just draw a little figure to see what's going on. So we have our ground, then we have our plane, and it's flying at an altitude of 5 kilometers. And it passes over the tracking telescope, and it makes some angle of elevation with that telescope, and let's call that theta. And then the distance between this point here where the tracking telescope is and this point here, if we draw a line vertically downwards perpendicular to the ground, let's call that x. Because if we can find dx dt, we find how fast the plane is traveling, and that is what we asked. So we want dx dt when the angle of elevation is pi over 3. We are given that d theta dt equals minus pi over 6 radians per minute when theta equals pi over 3. Because they tell us that this angle is decreasing at a rate of pi over 6 radians per minute when theta equals pi over 3. Okay, so next step is to find a relationship between our unknown quantities. The relationship that we can get here is that cot of theta equals x over 5. So what we want to do now is we want to get an equation where we have dx dt in, we have d theta dt in, and we can substitute the values that we have in there to solve for dx dt when theta equals pi over 3. So I'm going to use implicit differentiation. The derivative of cot is cosec of theta, cosec squared of theta, and it's negative, multiplied then by the derivative of theta, which is d theta dt. Then on the right hand side, I just have my constant 1 over 5, and then the derivative of x, which is dx dt. Now I'm just going to make the dxt the subject because that's what I'm looking for. So it gives me minus 5 cosec squared of theta multiplied by d theta dt. Okay, so what we want to do now is we just want to substitute in our values. So what we get is minus 5 cosec squared of pi over 3. Remember, we are looking for the dxt when theta equals pi over 3. And then we have d theta dt at that moment, which is minus pi over 6. So let's just quickly look at this. Cosec squared of pi over 3. Just going to draw a quick triangle here. This is pi over 3, pi over 6. And this is root 3, 1, 2. Cosec of pi over 3 is the same as 1 over sin of pi over 3. And that is just going to be 2 over root 3. And just remember that cosec squared of pi over 3 is the same as cosec of pi over 3 all squared. So what we have here is we have minus 5 multiplied by 2 over root 3 squared multiplied by minus pi over 6. And if you simplify that, you have 5 pi over 6 multiplied by 4 over 3. And you'll then have 20 pi over 18, which is 10 over 9 pi kilometers per minute. It's kilometers per minute because the quantities they give us in the beginning is measured in kilometers, and they also tell us it is moving at radians per minute. So our dxt will be in kilometers per minute. We are now at section 3.1's exercises. Number 35 says find the critical values of the function gy equals y minus 1 over y squared minus y plus 1. So let's just firstly recap what a critical value is again. So a definition of a critical number C is either the derivative of a function at that value is 0, or the derivative of the function at that value does not exist. So what I need to do here is I need to find the derivative of my function, and I need to determine whether there are any values where it does not exist, and I also need to determine whether there are any values where it equals 0. So I'm going to take my derivative of g, so it's going to be the bottom multiplied by the derivative of the top, which is 1, minus the top multiplied by the derivative of the bottom, which is just 2y minus 1, all over the bottom squared. Then I'm going to just multiply out my brackets. I have y squared minus y plus 1. Then I have minus 2y squared minus 3y plus 1 all over y squared minus y plus 1 squared. I can simplify my numerator a little bit. Then I get minus y squared plus 2y over y squared minus y plus 1 squared. I'm just going to leave the denominator as is. So we want to look at whether the derivative does not exist at any values. For the derivative not to exist, we know that this has to be 0. And at that values, it won't exist. But let's just quickly look at that. I'm just going to write that equation like this. And it's an equation of a parabola, right? A parabola with a y-intercept at 1. And will this equation ever equal 0? Well, let's just quickly look at b squared minus 4ac of this equation. That gives us the square root of minus 1 squared minus 4 multiplied by 1 multiplied by 1, which is the square root of minus 3. What does this mean? That means that that equation has no real roots. That means that that equation will never equal 0. So we have this will never equal 0. So the derivative exists everywhere. The next thing was we wanted to check when it equals 0. So minus y squared plus 2y has to equal 0, because if the numerator equals 0, the entire thing equals 0. So take out y as a common factor, y minus 2 equals 0. So that means y must be 0 or y must be 2. So the critical values is y equals 0 or y equals 2. The last one we're looking at is number 53. It says, find the absolute maximum and absolute minimum values of f on the given interval. F of t equals t minus the cube root of t, and it's on the interval that goes from minus 1 to 4, and it's the closed interval. So you have some steps that you have to follow in problems like this. The first step is we want to find the critical values, and then we want to find the values of f at those critical values. So step 1, find the values of f at the critical numbers of f in the open interval from minus 1 to 4. So to find the critical numbers, first thing I do is I find the derivative, which is going to be 1 minus a third t to the power minus 2 over 3, which I can write as 1 minus 1 over 3 to the power 2 over 3. So now we check two things. Firstly, does the derivative not exist for any values of t? Yes, it does not exist when t equals 0. So what we want to do now is we want to find the value of f at 0. So it's 0 minus the cube root of 0, which is 0. Next is we want to find where the derivative equals 0. So that will be if and only if 1 minus 1 over 3 t to the 2 over 3 equals 0. So that means that 1 over 3 t to the 2 over 3 must equal 1, which means a third must equal t to the 2 over 3, which means that t squared must equal 1 over 3 cubed, which means that t must equal plus or minus the square root of 1 over 27, and that I can write as plus minus, so the square root of 1 is just 1, so it's 1 over root 27, which is just 3 multiplied by root 3. So it's 3 root 3. So I'm done with the first part of the problem. What I want to do now is So now I've found where my derivative equals 0. So what I want to do now is I want to find the function value at those values. So I want to find f at minus 1 over 3 root 3. And let me just write down the function here again. F of t equals t minus the cube root of t. So this is going to be 1 over minus 3 root 3 minus, and then I have the cube root of minus 1 over 3 root 3. And 3 multiplied by root 3 is the same as 3 multiplied by 3 to a half, which is just 3 to the 3 over 2. So I'm just going to write this as 3 to the 3 over 2. Now, I know that this is just going to be minus 1 over 3 to the 3 over 2 to the power a third. And I can take that exponent in, and all I will be left with then will be minus 1 over 3 to the power a half. So, in other words, what I have now is I have minus 1 over 3 root 3 plus 1 over root 3. I can write it on one denominator, so I have minus 1 plus 3 over 3 root 3, which gives me 2 over 3 root 3. If I want to rationalize my denominator, I can get that it's 2 root 3 over 9, and then I get that that is approximately equal to 0.3849. So that was when t equals the negative, so it's minus 1 over 3 root 3. We also still have to check when it equals the positive, but the steps there will be very similar. So it's going to be f of 1 over 3 root 3. So I'm not going to do all of those steps, but the answer you get then is minus 2 root 3 over 9, which is then approximately minus 0.3849. So we've now completed our first step. Our first step was we had to work out our critical numbers, and then we had to work out the function values at those numbers. So we have f at 0, and then we have f at minus 1 over 3 root 3. We worked out is 0.3849, and then we have f at 1 over 3 root 3, which is minus 0.3849, sorry. Step 2 is going to be to find the values of f at the endpoints of the interval. And our endpoints was minus 1 and 4. So you find f at minus 1, it's 0, and f at 4 is 4 minus the cube root of 4, which gives you approximately 2.413. So this is our second step. Now, step 3 is simply you want to look at all of those function values that you've worked out, and you want to find the maximum and the minimum, because the maximum will be the absolute maximum and the minimum will be the absolute minimum. So of all of these values that we've worked out, we have a 0, then we have a 0.3849, we have a minus 0.3849, we have a 0, and we have a 2.413. So definitely this is our biggest one, and our smallest one will be this one. So we can say now that our absolute maximum is going to be f at 4, which is 4 minus the cube root of 4, and our absolute minimum is going to be f at 1 over 3 root 3, which is the same as f of root 3 over 9, which is minus 2 root 3 over 9. This is the end of this week's video.